Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Now we are in lecture 3 of S block elements. In this lecture, we are going to discuss more topics about S block elements. So please listen carefully. In S block elements, also we are discussing only about group 1 now. And in the coming sessions, we'll do about group 2 also. So please listen carefully. All these are very important for examination point of view. Yes. So S block elements, lecture 3, preparation of sodium chloride. Preparation of what? Sodium chloride. So now we are going to learn about some more compounds of sodium, that is sodium chloride. It is also called as rock salt. The major source of sodium chloride is containing seawater. From seawater, if you evaporate seawater in salt meadows, automatically you will get rock salt. So it is containing about 2.7 to 2.9% by the mass. So in seawater, sodium chloride contains about 2.7 to 2.9% by the mass. The sodium chloride obtained by the evaporation of seawater contains sodium sulfate, calcium chloride, magnesium chloride as impurities. So the sodium chloride obtained by the evaporation of seawater in salt meadows contains what are the impurities? Sodium sulfate, calcium chloride, magnesium chloride, as well as, so these are the compounds as impurities. The crude salt is dissolved in minimum amount of water to remove all insoluble impurities. Then the solution is passed by a current of HCl gas, which precipitates pure sodium chloride. So how sodium chloride is manufactured from seawater? First, seawater is being evaporated, and after evaporating of seawater, they form crystal salts. So that salt contains sodium sulfate, calcium chloride, magnesium chloride as impurities. And to remove these impurities, the crude salt, that is the impure salt, is dissolved in minimum amount of water to remove all insoluble impurities. Then the solution is passed by a current of HCl gas, which precipitates pure sodium chloride. So in this way, we will get pure sodium chloride, and calcium chloride and magnesium chloride remain in solution as they are more soluble than HCl. Next continuation. In this way, you'll get sodium chloride. Sodium chloride is used as common salt or table salt for domestic use in cooking purposes. It is also used in the preparation of sodium hydroxide, sodium carbonate, sodium peroxide, etc. So sodium chloride is used in the preparation of sodium hydroxide, sodium carbonate, and sodium peroxide, etc. Next continuation. Now sodium hydroxide. Causticizing process, it is also called as caustic soda. So manufacture of sodium hydroxide by the electrolysis of sodium chloride is also called as Kastner-Kellner cell. So in this Kellner cell, what happens? Brine solution is taken in one container. Here we have two compartments. This is the outer compartment, and these two are outer compartments. What are these called? Outer compartments. Outer compartments. Evaluate clearly. So these two are what? Outer compartments. Here I'm writing. You can adjust in that side also. In the outer compartment, what is taken? Brine solution is taken. What is brine solution? It is nothing but sodium chloride solution. Sodium chloride solution is taken as, that is also called as brine solution. So in the outer compartments, what is taken? Brine solution. And at the central compartment, this is called the central compartment or middle compartment. We can say this is middle compartment. Middle compartment. So this is called the inner compartment or the middle compartment. We can also call it as middle compartment. And at the base, what is kept here? This is called mercury, intermediate electrode cathode. So mercury will combine sodium and form sodium amalgam. So this is at the base, what is kept here? Mercury. And outer compartments are kept with brine solution. And central compartment, that is middle compartment, is kept with dilute sodium hydroxide solution. Then this has been here outer compartment graphite anode and graphite rods are kept, which are acting as anodes. So these two are graphite rods. These two are what? Graphite rods. The dotted ones I kept it as graphite rods. And here the intermediate is cathode. This is mercury is acting as cathode, and outer compartments brine solution graphite is acting as anode. Because from this experiment, definitely they'll give you based on experiment question also. This is also called as Kastner-Kellner cell. It is used in the preparation of sodium hydroxide, that is done by electrolysis of sodium chloride. So when you do electrolysis of sodium chloride, what will happen? You just see here now. So this is a diagram. This is the eccentric wheel where mercury can be inserted by the means of eccentric wheel. Mercury is being inserted in brine solution. How the mercury will come in contact with brine solution? By the means of eccentric wheel, which is used to send mercury to other members. Now, what happens at anode? Since sodium chloride is electrolyzed, what is sodium chloride? Sodium chloride brine solution is electrolyzed. When sodium chloride is undergoing electrolysis, brine solution at anode, when sodium chloride is electrolyzed, what happens? In the outer compartments, chlorine gas is formed at anode. At cathode, sodium combines with one electron and forms sodium mercury amalgam. As I told you, at cathode, what is formed? Sodium mercury amalgam. It is also called as amalgam. It is like paste-like structure. So the mercury will come in contact with sodium and form sodium amalgam. The sodium amalgam is treated with water to form sodium hydroxide and hydrogen gas. So this sodium hydroxide is formed at the central compartment. Now, properties. Sodium hydroxide is a white translucent solid. Sodium hydroxide is a white translucent solid. It is highly soluble in water to give strong alkaline solution. Sodium hydroxide is solid, is deliquescent. And the sodium hydroxide at the surface of solution reacts with atmospheric carbon dioxide to form sodium carbonate. So when you take sodium hydroxide in the container, at the surface sodium hydroxide is present. So this sodium hydroxide will come in contact with the carbon dioxide from the atmosphere and which forms to form sodium carbonate. So it is highly reactive. Sodium hydroxide is used in the manufacture of soaps, paper, artificial silk, etc. It is used in the purification of bauxite ore during the metallurgy of aluminium. It is also used as laboratory reagent for qualitative and quantitative estimations. Next, baking soda. Sodium hydrogen carbonate, it is called sodium bicarbonate, also we'll call it as sodium hydrogen carbonate, is prepared by saturating a solution of sodium carbonate by carbon dioxide. Sodium carbonate on reaction with carbon dioxide and water, it forms sodium bicarbonate. The sodium hydrogen carbonate being less soluble gets precipitated as white crystalline solid. So this will form precipitate. When sodium carbonate combines with the carbon dioxide and water, it forms sodium bicarbonate. Sodium hydrogen carbonate is used as mild antiseptic and is used in fire extinguishers. Sodium hydrogen carbonate, the important use of sodium bicarbonate is used in fire extinguisher because when sodium bicarbonate, when you heat sodium bicarbonate, what will happen? It forms sodium carbonate, that is Na2CO3 plus carbon dioxide plus water. So due to this, what happens? This carbon dioxide so produced. Carbon dioxide is not combustible, is not combustible, and it puts up the flame. It puts up the flame, puts off fire. So that's why. So the sodium bicarbonate is used in fire extinguishers because comes fast. If you heat sodium bicarbonate, means when you open the lid of sodium bicarbonate, what happens? Fire extinguisher, sodium bicarbonate gets converted to sodium carbonate, carbon dioxide, and water vapor. So the carbon dioxide gas, which is evolved from the fire extinguisher, will put out the flame, puts out the fire, or puts out the flame. That's why it is used in fire extinguishers. Very, very important point. So only sodium hydrogen carbonate cannot put out the flame. When you the sodium bicarbonate in the fire extinguisher changes into carbon dioxide gas. So thus that carbon dioxide gas is responsible for putting out the flame or stopping up the fire. Next, we have biological importance of sodium and potassium. Human being contains 0.13% of sodium and 0.24% of potassium by mass. We already have this because our body contains water and salt. So potassium by mass. Sodium ions are found on the outside of the cells, blood plasma, and the fluid which surround these cells. Sodium ions participate in transmission of nerve signals. Very, very important. For the use of sodium ions, it is used in the participation of transmission of nerve signals, regulating the water flow across cell membranes, transport of sugar amino acids into cells. So that's why the sodium is responsible. So our body also should contain salt percentage, then only it is good functioning. Next, potassium ions are the most abundant cations in cell fluids where they activate many enzymes. It participates in the oxidation of glucose, and with sodium it is responsible for the transmission of nerve signal. So glucose means oxidation of glucose means it is nothing but food, burning of food, burning of food in our body. So due to this, what happens? It gets oxidized. Burning of food can be done by potassium ions, by potassium ions, or the oxidation of glucose. Glucose is nothing but other form of food. So these are the biological importance of sodium and potassium. Now more about sodium and potassium compounds we'll discuss right now. So by taking new slides. So now onwards, it's very important to listen carefully so that we can cover everything about sodium and potassium right now. Continuation now. I'm sharing a white screen for you so that it will be shared in the form of PPTs. Just wait. Yes. Just trying to maximize this so that you can see everything clearly. Now let us see some important points about first group metals, that is sodium. Now, important extractions of first group metals. Extraction of alkali metals. This is additional information which is important for JEE mains and JEE advanced. So that's why this I'm giving. So extraction of alkali metals, sorry. Nothing but extraction of alkali metals. Alkali earth metals we can write better. So point number one, from first one we have preparation of lithium. So how lithium is being extracted, because this is additional information for JEE advanced. I'm writing here additional information for JEE advanced because you will not find this for JEE mains and even for NEET also. Is nothing but additional topic. So please note down. Next, lithium. The important minerals of lithium. How the extraction of lithium takes place. Important minerals of lithium are important minerals of lithium are first one spodumene. Spodumene is nothing but lithium aluminum silicate, lithium aluminum Si2, Si2O6. This is Si2, please note down. This silicon, and it is called lithium aluminum Si2O6. It is called spodumene. Next, we have amblygonite. Second one, we have amblygonite. It is nothing but amblygonite. It is nothing but lithium aluminum phosphate fluoride. Lithium aluminum phosphate. It is PO4 taken twice, and outside it is fluoride. Not. Next, we have. So this is nothing but the important minerals of lithium. Lithium are. So it is Li means lithium. What is this called? Lithium. So here I write lithium to avoid confusion. So important minerals of lithium are. So this is the third one we have. So these are the two main important involves. The extraction of lithium involves two steps. The extraction of lithium involves two steps. Step one, preparation of lithium chloride from minerals. Preparation of lithium chloride from the minerals. So first the OS heated about 1373 kelvins to convert it into more friable form, which is then washed with sulfuric acid. So first step, preparation of lithium chloride from minerals. Second step, electrolysis of lithium chloride. Electrolysis of lithium chloride. What happens when lithium chloride is electrolyzed? It forms lithium at cathode. It forms what is cathode? Lithium at cathode. So in this way, we'll prepare preparation of lithium chloride from the minerals, from these any of these two minerals, and next we'll prepare electrolysis of lithium chloride. Just only have to write down the steps so that it will be easy for you to understand. So when lithium chloride is undergoing electrolysis, it forms lithium at cathode. It forms what at cathode? Lithium is formed at cathode. Lithium is formed at cathode. Lithium is formed at cathode. So this is the additional information required from lithium. So that is extraction of alkali metals. First we have lithium we have done. Sodium already we have done in the given, that is Cashner-Killen's process and Downs process. Next, sodium if we take into consideration, just only these experiments are not there in the syllabus, just we have to note down this important this thing. Next, sodium. Sodium is extracted by the means of Cashner-Killen cell. First one, Cashner-Killen cell, which we have discussed already. Cashner-Killen cell. And second one, we have Downs process. What is it called? Downs process. So what is Downs process? So it is prepared from sodium chloride. Sodium extracted from brine solution. Sodium chloride is prepared from sodium chloride. So what happens? Sodium chloride on electrolysis. Fused sodium chloride on electrolysis, you will get sodium is formed at cathode. Sodium is formed at cathode. Very, very important. And this process is called as Downs process. So molten sodium and sodium is formed. Next we have potassium. Potassium is obtained by the electrolysis of fused. Next we have potassium. It is obtained by the electrolysis of fused KOH. Electrolysis of fused, very, very important, fused KOH, not aqueous KOH. If you take aqueous KOH, you will not get potassium. So fused KOH, potassium is formed at cathode. What is formed at cathode? Potassium, and oxygen is formed at anode. So next, so these are the main extractions of lithium, sodium, and potassium. Next, continuation. Now uses of sodium, potassium, and lithium right now here. Important uses. Uses of alkali metals. Lithium first, because we have discussed only few. So first, uses of alkali metals. Uses of alkali metals. First one, lithium. So lithium, very important use. Lithium magnesium alloy. Lithium magnesium alloy. Lithium magnesium alloy with 14% lithium. In this, what is this? 14% of lithium is there. Remaining is magnesium with 14% lithium. Is used for making aerospace component. Is used, lithium magnesium alloy is used for making aerospace components. Aerospace components. First use. Second use, lead lithium alloy is used for making electric cables. Lead lithium alloy is used for making electric cables. Electric cables. Third one, because uses they'll ask definitely in the examinations. Lithium hydroxide is used in the manufacture of lubricants. Lithium hydroxide is used as lubricant for oils and greases. For oils and greases. Next, fourth point. Lithium bromide. Lithium bromide is used as sedative in medicines. So this is about the use of lithium. Next we see use of sodium, then potassium. Next we have uses, sodium uses. Point number one. Sodium is used as reducing agent in the form of sodium amalgam. Sodium is used as a reducing agent in the form of sodium amalgam. Sodium amalgam is sodium plus mercury. Point number two. Molten sodium or its alloy with potassium, sodium and potassium alloy with potassium is used as coolant, is used as coolant in nuclear reactors. In nuclear reactors. Since we are learning the lessons, we don't know the proper use of these. Definitely they'll ask uses in the examination. So that's why I'm giving additional information. Sodium is used for the sodium is used for refining of metals, refining of metals, refining of metals such as zirconium and potassium, such as zirconium and potassium. Next, fourth point. Sodium lead alloy. Sodium lead alloy is used in the preparation of so these are the important uses we have is used in the preparation of tel. What is this tel? Tetraethyl lead. Tetraethyl lead, which is used as anti-knocking agent in petrol, which is used as anti-knocking agent in petrol. So these are the important uses of sodium. Next we have use of potassium. Potassium uses. Let us start with potassium uses. First one. Potassium chromate. Potassium vapors are used in magnetometers. Magnetometers. Next, second point. Potassium nitrate. Potassium nitrate is used as fertilizer. Third one, potassium dichromate. Potassium dichromate is used in manufacturing ink. Is used in manufacturing ink, comma, dyes, ink, comma, dyes, safety matches, fireworks, etc. Safety matches, fireworks, fireworks, tanning of leather, etc. Tanning of leather, etc. So these are the main important use of potassium. Next we have rubidium. Rubidium uses. Because they'll ask questions from this also. That's why I'm giving all the additional information for JEE Advanced. Rubidium, first it is used in photocells. It is used in photocells. Second point, it is used as rubidium 87. Rubidium 87. Rubidium 87 is radioactive. Is isotope of rubidium is radioactive and is used in the aging of rocks and is used in the aging of rocks to determine the age of rocks. Third point, rubidium salts. Rubidium salts are used in glasses and ceramics. And fourth point, we have rubidium compounds give purple color in fireworks. Rubidium compounds gives purple color in fireworks. Next, cesium. So what are the important uses of cesium? It is used in photoelectric cells. Photoelectric cells used in photoelectric cells, comma. It is used as catalyst. It is used as catalyst in the hydrogenation of few organic compounds. In the hydrogenation of few organic compounds. So organic compounds get undergoing hydrogenation when you present in the presence of cesium catalyst. Next important point is used in alarm clocks. Cesium 133 is used as cell in alarm clocks. Is used as cells in alarm clock. Cesium 133 is isotope of cesium. Cesium 133 is isotope of cesium. So these are the important use of alkali metals. Alkali metals. Next, some important questions based on alkali metals. Now we are going to discuss. So next questions based on alkali metals. MCQs and reasoning type questions. Reasoning type questions. These questions are very important. So that's why I'm giving option. First question: why potassium is less reactive than rubidium? Less reactive than rubidium, because nowadays they are giving in JEE mains even objective based question, that is integer answer type question. So that's why these reasoning type questions are also very important. So for this the solution is, so due to its due to its small size due to its small size and high ionization enthalpy and high ionization enthalpy, potassium is less reactive than rubidium. Potassium is less reactive than rubidium. So this is the answer. Next question number 2. Why alkali metals? Why alkali metals, when dissolved in liquid ammonia, dissolves in liquid ammonia is always blue color. Liquid ammonia solution is always blue color. So answer for this, due to solvated ammonia electrons, they absorb red light, and they absorb red region of the visible light, and gives complementary blue color. Complementary blue color. So this is another important question. Next, question number 3. Which of the following alkali metals? Which of the following alkali metals is the strongest reducing agent. Is the strongest reducing agent. So this answer everyone knows. You can recollect. Option A, it is lithium. Option B, it is sodium. Option C, it is cesium. And option D, it is potassium. So answer is for this solution is what? Lithium is the strongest reducing agent due to its lithium is strongest reducing agent because its electrode potential value of lithium plus 2 lithium is equal to reduction potential value is equal to minus 3.04 volts electron volts. Next question. Question number 4. So all these questions are very important. Most of the lithium compounds are covalent in nature except lithium fluoride. Why? So the answer for this is so lithium fluoride is covalent, so ionic. Why? Since solution now. Fluorine is more electronegative, is highest electronegative element in the periodic table, and hence lithium fluoride is ionic in nature. Simple as such. Next question. Question number 5. These are the important questions we have discussed now. So some important questions I'm writing here now. Please note down. Question number 5. Yes. Which are the following salts? Which of the following salts does not form any precipitate so the following salts does not form any precipitate with excess of sodium hydroxide with excess of sodium hydroxide Option A, it is zinc chloride. Option B, it is ferric chloride. Option C, it is chromium chloride. And option D, it is copper sulfate. So answer for this is zinc chloride. Zinc chloride does not form any precipitate with excess of sodium hydroxide. Next question number 6. The electrolyte used. The electrolyte used in Kastner-Kellner process is Kastner-Kellner. This we have done in this lecture only. Kastner-Kellner process is Kastner-Kellner process of sodium extraction is first option A, anhydrous sodium bicarbonate, sodium carbonate, anhydrous sodium carbonate. Option B, aqueous NaOH. Option C, NaCl plus CaCl2. And option D, we have fused anhydrous NaOH. Fused anhydrous NaOH. We have seen in the central compartment the electrolyte. So what is the electrolyte used in the Kastner-Kellner process? So it can be anhydrous sodium carbonate, aqueous NaOH. So what is the answer might be? You can write here itself. I'm writing here. Please note it down. So it is question number 7. Fused anhydrous NaOH. What is this called? Fused anhydrous NaOH. Because in the central compartment you have seen it is present in central compartment. Next, question number 7. So based on experiments also you'll get questions. Question number 7. Which among the following which among the following which among the following is least soluble in water? Least soluble in water. Option A, it is lithium chloride. Option B, sorry, it is lithium fluoride. Again, I'm writing the option lithium fluoride. Option B, it is sodium fluoride. Option C, it is potassium fluoride. And option D, it is rubidium fluoride. So we already know ionic compounds are soluble in water, but in this, which is least soluble in water, since lithium fluoride is usually lithium compounds are covalent, but lithium fluoride is ionic because lithium fluoride also forms ionic compound. So answer for this option will be, you have to know the option. So answer for this option will be option A, that is lithium fluoride. Even though it is ionic, it is still least soluble in water because all these are highly ionic. Next question. So this type of questions are important for objective point of view. Sodium hydroxide plus carbon monoxide gives on heating at a temperature of 200 degrees C and a pressure of 1 atmospheres, that is atmospheric pressure, sorry, 5 to 10 atmospheres. 5 to 10 atmospheres forms a compound A. The product A is option 1, sodium bicarbonate. Option 2, sodium carbonate. Option 3, it is sodium acetate. Sorry, it is, yes, HCONA. It is sodium acetate. Sodium formate, actually, this is called sodium formate because only one H is there. And option 4, it is carbonic acid. This reaction is very important. Sodium hydroxide on reaction with carbon monoxide at a temperature of 200 degrees C and 5 to 10 atmospheres, it forms compound A. So what is A? What is A? A can be sodium bicarbonate, sodium carbonate, sodium formate, and sodium form, carbonic acid. So answer is sodium formate. Very, very important. Sodium formate. What is this called? Sodium formate. It is an organic compound. Next question. Question number 9. The material used in solar cells contains the material used in solar cells contains, this answer you know because we are done just now. It is cesium. Option B, it is silicon. Option C, it is tin. And option 4, it is titanium. So answer is cesium. Next question. Question number 10. So like this uses also, this is previous JEE means question 1993. So that's why it is very, very important. That's why I'm giving all the questions. Next question. The products of the products of electrolysis of the products of electrolysis of concentrated common salt, concentrated common salt solution, are option 1, it is sodium plus chlorine. Option B, concentrated, they are given, very, very important, H2 plus O2. Option C, sodium hydroxide plus H2 plus Cl2. Option D, we have sodium hydroxide plus H2 plus O2. These are the 4 options we have. This is the products of electrolysis of concentrated common salt solution. Excuse me. The products of concentration of concentrated common salt solution are, it is NaOH plus H2 plus Cl2. NaOH plus H2 plus Cl2. Why? Because when you take sodium chloride, concentrated sodium chloride, on electrolysis, what happens? It forms sodium ions at cations, sodium ions as well as H plus ions. But H plus ions will go to cathode and forms hydrogen. And chlorine ions will go to anode and forms chlorine, will go to anode and forms chlorine molecule. So hydrogen is formed at cathode and rest is present is inside the solution, sodium ion and OH minus ions also there. So the sodium ions and OH minus ions combine together and form sodium hydroxide. So the electrolysis products of concentrated sodium common salt solution are sodium hydroxide kept in a cylinder, hydrogen gas is formed at cathode, and chlorine gas is formed at anode. So hydrogen gas is formed at cathode and chlorine gas is formed at anode. Very, very important question. Next question. Question number 11. When sodium carbonate is added to aqueous solution of copper sulfate, aqueous solution of copper sulfate, CuSO4. Option A, copper carbonate is precipitated. Copper carbonate is precipitated. Option B, copper hydroxide is precipitated. CuOH taken twice is precipitated. Option C, basic copper carbonate is precipitated. Basic copper carbonate is precipitated. And option D, I have written in short form, please try to understand. No reaction takes place. So like these questions are most important. Now we'll get the idea, but when you are writing for the entire chapter syllabus, so that is nothing but for the entire syllabus of 11th and 12th, it will be difficult to strike at this moment. So that's why you have to be thoroughly practiced with all these things. So answer for this, option A, option B, option C, option D. So basic copper carbonate is precipitated. What is the answer? Basic copper carbonate is precipitated because so it forms Na2CO3 double decomposition H plus CuSO4. It forms CuCO3 plus Na2SO4. And since sodium carbonate is basic in nature, so this will form basic carbonate, basic copper carbonate. Basic copper carbonate is formed. Very, very important. Next question. Question number 12. Which of the following alkali metal? Which of the following alkali metal do not form alum? Alum is what? It's a the mixed salt, double salt. So option A, it is lithium. Option B, it is sodium. Option C, it is potassium. And option D, it is rubidium. So which of the following alkali metal do not form alum? Which of the following alkali metal do not form alum? So let us see the answer now. It is easily we can say it is lithium. It is what? Lithium. So lithium is a metal, alkali metal which do not form alums. Next question number 13. So we'll do up to 15 questions, then we'll end this session. The stability of alkali metal chlorides. The stability of alkali metal chlorides follows the order. Metal chlorides follows the order. For this, I'm not giving options directly. I write the solution because then the options are there. So answer for this is follows the order. So it can be potassium, cesium, sodium, and lithium is given. So now the answer for this is writing the direct option here. I'm writing. Try to understand that. It is potassium chloride greater than cesium chloride greater than NaCl greater than lithium chloride. So the stability, very, very important order. Please note down. Stability, potassium chloride, it is not forming following general trend. So potassium chloride is least stable, greater than cesium chloride, sorry, strongest stable due to its hydration enthalpy. Cesium chloride, then sodium chloride, then lithium chloride. This is the stability of alkali metals. The stability of alkali metals follows the order. Very, very important. Next question. Question number 14. Next question. The carbonate, the carbonate that will not decompose, that will not decompose on strong heating. The carbonate that will not decompose on strong heating is option A, it is sodium carbonate. Option B, it is calcium carbonate. Option C, it is strontium carbonate. And option D, it is barium carbonate. So the carbonate which will not decompose on strong heating is sodium carbonate. Sodium bicarbonate will decompose on heating, but sodium carbonate does not decompose on strong heating. Very, very important question. Next question number 15. So the last question in this session. Then we'll continue with the other topic in the next session. Which one of the next question? Sodium peroxide. Sodium peroxide is yellow in color. Yellow solid is yellow solid. When exposed to air, it becomes white. When exposed to air, it becomes white. It becomes white due to the formation of due to formation of this question is also very, very important. Option A, it is hydrogen peroxide. Option B, it is sodium oxide. Option C, it is sodium oxide and O3. Sodium oxide and O3. And option D, it is sodium hydroxide and sodium carbonate. Sodium hydroxide and sodium carbonate. Very, very important question. Please note on this. So, sodium peroxide, which is yellow solid when exposed to air, it forms. When exposed to air, it becomes white. It is due to the formation of sodium hydroxide. Already we know when peroxide is exposed to air, it forms hydroxide, that is sodium hydroxide and sodium carbonate. So answer is D. Answer is what? D. Very, very important. So like these questions we are expecting in the entrance examination. So all of you please take care and do many questions of this. More questions you do in from other material. So with this, I'm ending this session. So we have done 15 questions and some important uses of alkali metals and also preparation and properties of sodium hydroxide, sodium carbonate, etc. And we have done questions based on that also. In the next session, we'll come up with a new topic. Thank you all.